Thank you again for the reminder to record. Here's our divisor. And what I want to do, Andrew, is I want to look at the first term of the divisor and the first term of the dividend. All right, Finley, zip it. First term of the divisor, first term of the dividend. And here's what I'm going to ask you to do. I'm going to ask you to figure out what would it take to multiply by 2x to get you to 2x cubed. X squared. And you say x squared. And that's going to be the first term of your quotient. Because when you multiply, and that divisor being a binomial, we're going to have to multiply twice. When you multiply, you want that first term to cancel out. You want that first term to cancel out. So x squared times 2x will be 2x cubed. X squared times negative 3x is negative 3x squared. All right. And then after you multiply, you subtract, which means change the sign of both those terms. So these two guys should cancel out by design. It's not a coincidence. They cancel out by design. Franklin, question.
Can you go back right before you put down the 3x squared?
What's up?
So I know how we got the 2x cubed, but can you just bring down the 3x squared?
No, we multiplied. Look at these two little arrows. X squared times this and x squared times that.
Okay.
And that gave us these two. Gave us these. Mario? Then you've messed something up and you got to figure it out. You're starting to think of challenging examples, like if it was, shucks, hold on. If it was like 2x and this was like 5x cubed, stuff like that.
Yeah. Like
you'd have a fraction. So like in this case, what times 2 gives me 5? 5 halves. You know what I'm saying? So like in that, for instance, I could still get it to match up and then subtract and cancel out. It just would have a fraction in it. Only the first term. Only the first term. Blake? I always get that question. Anybody know? Wait.
Using both. That's the last column. Because that one has.
What term is this? What term is this? What term is this? Bazinga. We line it all up. Mike?
Oh, when you put the sign.
Ooh, let me go back and flip that sign because Franklin asked me to. No, when you subtract a binomial, you got to change the sign of each term in that. That's what we change. Freddie? Yeah, that usually won't happen. It usually will not happen that the second one cancels out. Christian, you got fuzz in your hair. Somebody threw some paper in you. Oh, no, actually, that's the glasses. Never mind. Your glasses were camouflaged. I thought it was the Mario?
If it doesn't cancel out from there.
Well, watch what the first one's always going to cancel out. This one actually does cancel out, so you got to bring down both of them. So negative 8x and positive 12. If this one didn't cancel out, you would only bring down the one and you'd have your two terms and you'd repeat the process that way. All right. Speaking of Christian, help me out here. What times 2x is going to give me negative 8x? What kind of 4? Good. So we'll say negative 4. And again, to Blake's point, where did I put the 4? That's just a habit. You don't have to do that. You don't. It's not necessary. I just like doing that for my sake. And then after we write that up at the top, we multiply. Negative 4 times negative or times 2x is negative 8x. Negative 4 times negative 3 is 12. After you multiply, you subtract, which is change the sign, cancel out. Your remainder is 0. And ooh, that's very nice. Sir.
0.
No, there was a linear term there already. Sure. Oh, are you talking about up here?
Yeah.
No. You don't have to.
X.
Why is it a negative 4?
Because negative 4 times positive 2x, it could be negative 8x, and that's what I wanted. I want this first term to match up identically, because then when I go and subtract and change the sign, it will cancel out.
Okay.
Sorry?
Would your remainder be if the very last term doesn't cancel out? Like
Yeah. So like if this was, let's just make something up. This was like 13. 13 minus 12 would be 1. You'd have a remainder of 1. And how do I write my answer up?
Squared minus 4.
Wrong. There we go. Good. Y'all gonna be grumpy with me for saying this. The way that you, gosh, sidebar example, get out of here. The way that you write your example up, or your answer up, is you express the dividend over the divisor as the quotient plus the remainder over the divisor. Why don't I have a remainder over divisor here? Because the remainder was 0, there was no remainder. Now, that means that this right here is an interesting result. Let me get this other stuff out of the way. Why is this an interesting result? Well, what kind of numerator is that?
Difference, boy.
Numerator. It's degree 3, so we call it a cubic polynomial. And when you got a remainder of 0, what that meant was that you could actually multiply both sides by this divisor. Check this out. You can multiply both sides by the divisor and get 2x cubed minus 3x squared minus 8x plus 12 equals x squared minus 4 times 2x minus 3. In other words, you wrote a cubic polynomial as a product. That process is called factoring. So congratulations, you just factored out a polynomial of degree 3 that you previously were not able to factor out. Because in this certain circumstance, I gave you a foot in the door, I gave you a divisor that happened to be a factor of the dividend because you had a remainder of 0. Okay, and so that's called the factor theorem. What we just had happen is called the factor theorem. When you have a remainder of 0, you could change the division algorithm from dividend over divisor equals quotient. You could times both sides by divisor and write the dividend as a product. So this is a backdoor way of factoring when you get a remainder of 0.
What groups that cubic?
Probably so. I usually make up the first example to where it works out pretty nicely.
Okay.
I think so. And this would have factored further as x plus 2x minus 2, but that's not the point of the example either. Christian, was that your question? Yeah. Oh, Smith, you good?
Good.
Awesome. Thank you. All right, so factor theorem says if I get a remainder of 0, that means that, hey, the divisor was a factor of the dividend, and therefore I could write the dividend as a product. And that's going to be very useful for us, okay? But you kind of have to have your foot in the door, so to speak, and I gave you that 2x minus 3 as a potential divisor for you to check out there. Okay? Everybody good? Finley, you napping? I got caught napping yesterday at the vet. You know how they take you back to a room when you go to the doctor and they like, okay, the doctor will be in a little while to see you. And so Sonny laid at my feet and I just laid in the chair and I fell asleep. And then I woke up and the vet was staring at me. And I was like, what is going on? Okay. So Finley, we're not at the vet, so don't be sleeping. Here we go. And what's my admonition for us in orange? Don't skip terms. Did I skip any terms?
Yeah.
I sure did. Which term? Good, that's the linear term. So we can, instead of skipping a term, very good, Franklin, we can put in a little 0x. So we got 5x to the 4th, 6x to the 3rd, 12x squared, 0x minus 3. X squared plus 0x plus 3. Notice I wrote up my 0 placeholder in both spots. Do not skip terms. Put you a 0 placeholder in, and life will be much better. Life will be much better. Like,
Wait, why did you put it in the x squared?
because it skipped a term. It went from quadratic to constant, and it skipped a linear term. So if your dividend or divisor, either one skips a term, put that 0 placeholder in. Trust me, it will work out way better that way. All right. Anybody seen Henry today? Been gone. All right. So here's what I want to do. I want to consider the first term only, x squared, 5x to the 4th, and Aiden, what is something that we could times by x squared to get 5x to the 4th? Good. So I'm going to put 5x squared up top. Beautiful. Blake just asked that question. Blake, see if you can answer it for us. Just a second. I'm going to make sure I got Henry marked out. Yep.
5 or 6 are trying to dividend downwards. We still have to put it in.
Well, look, there, I'll be honest with you, there are some times where you could probably get away with it without putting a zero placeholder in. But I kind of feel like if you get in the habit of every time it skips a term, every time you put in a zero placeholder, you're going to be straight.
But regardless of.
Correct. Correct. Mhm. All right. Can we do our, did I unfreeze? No. Can we do our multiplication? All right. Let's see if Jack can give me my 3 products resulting from the multiplication. Beautiful. Sebastian, after you multiply, you. Excellent. And that means I'm going to change all the signs. Now there's 3 signs to be changed. 1, 2, 3. There we go. Some textbooks don't actually physically change the sign. I highly recommend that you do physically change the sign, because then we can tally stuff up. Fredo, this first one cancels by design. So tell me what my next 2 will be. And then I bring my next one down and repeat the process. Phil, what do you want to multiply by? Fantastic. All right. And Kenneth, you want to do that multiplication for us? Good. Mitch, after we multiply? Good, that boy. Subtract. So subtract, 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 change signs, change signs, change signs. Cancel that first term out by design. Eli, roll through my next 3 terms. What are they? Good. And that -3, we bring it down. Freddie, what do you want to multiply by? Am I going too fast, by the way? Or are we okay? Okay, so we'll slow it down just a bit. Freddie, what times x squared will get me -27x squared? Good. So we're gonna put that up top. And so I don't know, have y'all ever played with a Rubik's Cube? I use this analogy all the time with this process. Like Rubik's Cube, there are certain little algorithms you can do, like turn the right side forward, turn the top side to the left, turn the right side backward, turn the top side to the right. And you repeat these little algorithms and it affects a change. And then if you do it enough, you get back to what you started with. And so one way of solving a cube is memorizing a set. I think there's 6. Memorizing a set of algorithms, like you, and then that gets the top row done, and you turn it over, and then that gets the bottom row done, and then you get the top row done. And so that's kind of like what we're doing. I keep asking these same questions. What do you want to multiply to this to get that? We write it, then we multiply, we cancel out, bring down, and repeat. Repeat. And then 6x times this, got this, we subtract, we bring down, and now we repeat. So -27, Mitch, I want you to help me do that multiplication. We're going to do -27 times all 3 of those guys. Good. Good. -81. That's a math fact I'd like you to learn. You asked me about that the other day. 3 to the 4th power is 3 squared times 3 squared, 81. And since 27 is 3 to the 3rd, and you're wanting to multiply one more 3, that's a helpful fact. It shows up a lot. 3 to the 4th equals 81. All right, and so Mitch did a good job of helping me multiply. Franklin, you want to help me change the sign? Subtract. Yeah, that one don't matter. Good. So that means, Nash, what kind of remainder will I have? Well, I mean, like specific, what's the remainder? Negative 18 x plus 78. Beautiful. And did y'all make note of what he was saying that's over here on the left? I hope you wrote this down at least, that you can stop once the remainder is of less the degree than the divisor. The divisor being quadratic, the remainder is linear. I can stop because linear is degree 1, quadratic is degree 2. And how I write my answer up very much matters here. Let's do this. So I got 5x to the 4th plus 6x to the 3rd minus 12x squared minus 3, all divided by x squared minus 3. And that's going to equal 5x squared plus 6x minus 27. And then a big fat plus negative 18x plus 78. Ugh. Hold on. Let me make a little more room. Plus 78, all divided by x squared plus 3. That'd be how we'd write our answer up. It's look, the quotient something didn't get moved. That's weird. Oh well. Something got off kilter. The dividend over the divisor equals the quotient plus the remainder over the divisor, and having a remainder of 0 is ideal. It didn't happen in this case, so that means that x squared minus 3 is not a factor of the dividend. But this should be a plus. Thank you. Good catch. Who else had a hand up? Or was that same question? Good catch. Yeah, that's oversight on my part.
Oh, would it be wrong if we send it to 0 on my answer?
No, not at all. Okay. Raise your hand if you did this as an Algebra 1 student. Okay.
Did we do it in this class?
That's all right. Very nice. This show's all. Okay, so now what we can do is we can start asking a little bit different question, and what that will check to see is if you understand the process of what you're going through. And for example, it says here it's x plus 4 a factor of that cubic polynomial. If so, find any other factors. Now, what they actually want you to do, without coming out and saying it, is they actually want you to do the division here. Because to check if something is a factor, you can do the division. Jenny Morgan last night on the van ride going to football. She was working on some math homework, and she said, Dad, is 3 a factor of 23? Okay, now you guys are old, and y'all know that the answer to that question is no. Jenny, the youngster, was trying to figure it out. And so we went through and we talked a couple of different techniques. One thing I did not tell her to do is actually do the long division. I don't know if she's learned long division yet or not. But like you could do 23 divided by 3, and you'd get 7 with a remainder. And so because the remainder isn't 0, we would tell Jenny, yeah, 23 is not a multiple of 3. Or other way, 3 is not a factor of 23. That's the same exact thing that we're doing here. It's just replace your 23 with that cubic polynomial. Replace your 3 with that linear divisor, right? And check and see if you get a remainder of 0. Remainder of 0 would tell us if it's a factor. Okay? So let's try and do that. And let's try and work a little bit quicker on this one, just so that y'all can practice doing these at speed. By the way, did I skip any terms? Good. Always look for that. Oh, good catch. Thank you. I'm slipping today on a Friday, man.
The weather's messing with me.
Hey, Mitch is locked in over here. Blake's locked in.
I mean, I'm not though.
Why are y'all quacking like us?
The right side of the room for left.
I guess. Maybe you step it up over here, Denegri.
Yeah, little bro.
All right, here we go. Andrew, you can start us off. What times the first term is going to get us the first term? X squared. Good. And I'll put that over the X squared just because that's my normal way of doing things. After we write that up, Freddie, wake up. After we write that up, what do? Subtraction. Before multiplication, I don't know how I would do that, but we're going to multiply.
Then you subtract.
There we go. X cubed or X squared. All right, so we're going to change the sign of both these. They're both positive. Now they're negative. Cancel by design. Negative 6x squared. Bring the negative 51 down. Repeat the process. All right, Michael, what do you think? What kind of 6x? Well, I like 6x, but I don't like the sign. Negative 6x, because I'll get negative 6x squared and negative 24x. After I multiply, change the sign, cancel by design. Ooh, mama, 27. All right, so negative 27. Negative 27x. What's negative 27 times 4? Negative 108. Change the sign. Cancel by design. And then what's our remainder?
0.
Oh, baby. Okay. So how would you answer the question? First of all, is that a factor? What do you think?
Yeah.
We would definitely say, yes, it is. Okay. So we're going to answer. It's a yes question. So we say, well, yes, it is. And it says, if so, find any other factors. Okay. What do you think, Kenneth? All right. So I'm writing my dividend as a product of x plus 4, that's the divisor, times the quotient, x squared minus 6x minus 27. Now, no, boy. It smells like this one could be broken down with a 9 and a 6, or excuse me, a 9 and a 3 to get 6, but I got to get the signage correct. What kind of 9? What kind of 6? So x plus 4, x minus 9, x plus 3. And oodalali, look at that. We took a degree 3 polynomial and we wrote it as a product of 1, 2, 3 linear factors. That is very correct.
Wait.
Slow up. So let's just make sure we heard what Mitch said. So in blue here, we've got this cubic equation, which before today, dadgum, you would not have been able to solve a cubic equation. Okay. And just because you got your foot in the door with this long division and you realized, oh snap, negative 4 is a root of that. It's as though you're pulling that root out. And now the resulting factor is a quadratic, and we know how to handle quadratics. And this smelled like factoring. And we said, oh, okay, I got 2 more answers that way. So in blue, our 3 solutions to that quadratic equation would, or excuse me, that cubic equation would be x equals negative 4, negative 3, or positive 9. Okay. All because you had a remainder of 0. Factor theorem is very powerful. Kenneth. Bless you. 51 does not go into that. So maybe, I don't know. 51 and 108 are both multiples of 3. So like you could try grouping and factoring, but I don't think it works.
I was wondering.
Yeah. So, well, it's a maybe an alternative method, we could say. But you got to get your foot in the door. You got to know. In this case, I gave you x plus 4 as a potential, and you tested it by doing a long division. And because it tested well with the remainder of 0, you were like, oh, okay, we can factor that out then. And
Is there any variable? Like Anthony.
If this had not been 0, we would have said no here and we would have thrown on the brakes and couldn't do anything else. Smash.
Oh, we have a go.
Yes, you will. Yes, you will. Why don't you guys try one on your own? Eli, you got a question? You should. On the last one? I thought I saw you raise it. Okay. All right, y'all try this one on your own. Just do the division. Just do the division.
Hey, boo.
Oh, welcome to the party, Bentley. I'm glad you woke up.
I don't consider this job, but.
Oh, maybe Freddie and you had decided today was nap time.
For dog.
It's not time.
It's game day. It's game day.
All right.
Freddie, I'm just messing with you, man. It's all good.
It's my head hurt time.
You got.
Brandon.
Hey, when Mitch says something, why are y'all going?
We said that.
Oh, okay. Gotcha. I thought it was just a Mitch thing. I was like, no, we're not Mitch. All right, let's test him out. Nash, say something.
It's like that villager from Minecraft.
Do what?
It's like that villager from Minecraft.
Buckle, you don't count, but you're in the business.
Y'all sound like Waluigi. Yeah.
Oh, God, me.
See, now that I hear
Oh, wow. Oh, wow,
You know, they're dropping a new Mario Party.
Well, they are.
Jubilee? Is it Jubilee? What? Jubilee? Ooh, and the new Zelda came out yesterday.
That goes with.
Ooh, that's tough.
They made another.
This one you can play as Zelda for the first time, like the whole game. And she has like a magic wand and she can duplicate things and then trick bad guys with it.
Ooh, cool.
I think they're trying to get the female demographic to be excited about it.
Oh, you want. I just want to play it on you. You can also play.
Cool. Here, work. Do you have this one written down yet? All right, well, here, let's get the ball rolling. Hey,
Whoa.
hey, hey, dang. Hold up. I'll take that knife out your back.
And throw it in his.
All right, so we're gonna start there. Hey, brother, we're gonna start there. There you go.
You, on the Monday mornings, you give me a nice little detailed scoop.
I've been hearing so much good feedback on that. There we go.
That's the Mondays I get that.
Speedo.
Yeah, ooh.
Really?
When the Waffle House is closed.
That's like the sign of
bad.
the sign of the apocalypse.
There's an action there, like, that whole house
The
style,
Waffle
like,
House
that.
does that.
Yeah,
If it's like completely shut down, it's.
you're in trouble. The poop has hit the fan.
Hours on, it's like.
I will say this. Hey, love me some Waffle House. Hash browns, scattered, covered, and chunked. That's the way to go.
Ever crispy.
But you got to get them scattered. That's why. Like scattered means they spread it out on the griddle. Covered means they put some cheese on top of it. And chunked means they cut up ham and put it in there.
I can go down there, cook, make your hash browns. They are like crunchy little.
Oh, there you go.
Ketchup on there.
Oh,
My dad puts chili in it.
hey, you're going to hear one of these tonight. You're going to be like, I want hash browns.
Bothered you long.
See you, brother.
My dad puts chili in it.
Pretty good. All right, so back to this, Mitch, you were asking. So like at least the first thing I can do to get the ball rolling is know which one's which as far as dividend and divisor. The dividend is the numerator fraction or what comes first. It goes inside the house. Divisor goes on the outside. I didn't skip any terms, so we're kind of setting ourselves up for success here. All right. And then the quotient goes up top. We get the first term of the quotient by identifying what would I multiply times x squared to get 3x to the fourth? And we'd say 3x squared. And so 3x squared goes up top. And then we start our process. We multiply 3x to the fourth, negative 6x cubed, and 3x squared. After we multiply, subtract, which means change the sign, cancel by design, 7x cubed, negative 20x squared, bring one down, pass it around, 99 bottles of root beer on the wall. All right. 99 bottles of milk on the wall, 99 bottles of milk. You know that song? Well, you can substitute milk or root beer or whatever you want. Sebastian, I don't want to see your belly button tucking out in or quit stretching. Actually, Sebastian, hit me up. What's your next term on the quotient going to be? Shh. Beautiful. All right. So 7x cubed, negative 14x squared, and 7x. Hey, little pro tip for you. This is just the tip. Don't be weird. Change the sign of each term. If I know I'm going to change the sign, I'm not going to put a plus there because with a plus, I have to flip it around and erase the plus. So I just leave the plus blank in front of it. But if it's a minus, I go ahead and write the minus because I could easily turn a minus into a plus.
So no matter what the sign is, I change it.
Correct. All right. Negative 6x squared. And 12x. Can I stop yet? We don't stop. Bring down that negative 6. And then negative 6 is 6x squared. 12x, negative 6. Change the sign, change the sign, change the sign. Cancel by design. 0 winds up being the remainder.
About that show? Never mind. I messed up. It's okay, Gilmore. We all make mistakes. 19x.
All right. Would you? Oh, go ahead.
Are we doing it backwards?
No, we don't have to worry about that. Would you like a shortcut?
Yes.
I love a shortcut.
Do you already know the shortcut?
Yes.
Somewhere in there.
Usually, it's been about 50-50 on the number of years that I teach the shortcut to the Algebra 1 kids. So my kid, I did. It's hard for a freshman or eighth grader to get it though. But it's called synthetic division.
That sounds fancy.
This is what it looks like. It's it's wild. All right. Well, let's just get the broad strokes today. Let's get the broad strokes today of what synthetic division is. Number one, synthetic division is a shortcut for long division.
Doesn't look like it.
It is. You're gonna love it. It's like one of my favorite things to do in algebra 2. It really is. It's a shortcut for long division. It only works in certain circumstances. If the divisor is linear, you can use it. If the divisor is nonlinear, sorry, you got to do long division. Now, in calculus, we do both long division and synthetic division. So this, you will see this again next year or the year after next, and your teacher will expect you to be good at it. Both long division and synthetic division. And it'll be one of those things that he or she just drops in the middle of a problem, and they'll be like, oh, we can tell this degree 5 polynomial, it's got this one root, and we can siphon that root out by using synthetic division. And you're going to be like, oh yeah, I remember that. And if you don't remember it, and you're like, wait a minute, what? They're going to be like, oh, go teach it to yourself again, because you should already know this. So that's why I'm teaching it to you. We're going to take our time and learn it real well. The long division, we worked 3 examples of. Synthetic division, we won't have time to work 3 examples today, but we will next week. Okay. Synthetic division, shortcut, only works with linear divisor. And we want to put our divisor in the form of x minus k. So make sure you focus in on that x minus k. So if the divisor has a linear coefficient, like if it was 2x minus 3, I'm going to have to factor that 2 out. And I'll show you what that looks like. Okay. But you want it to be able to form x minus k. It's a lot faster than long division. Okay. Now I'll show you just up here in this space what it looks like. And you're going to be like, what? Okay. Yes, sir. If need be, temporarily factor out the linear coefficient. So like that's what I was saying. If this was like 2x minus 7 or something, you would bring a 2 out and you'd have negative 7/2 would be your k value. All right, so here's what I'm going to do. I'm just going to shut up and show you what synthetic division looks like. All right, so I've got my answer now. I got my answer now. And I'm gonna walk you through this, but did you see how fast that went? And did you notice I was just using what? Only using numbers. There was no variable. There was no, x cubed or x squared or x. It's way fast. And by the way, my remainder of 0 over here, that's a good thing. So I know that x minus 2 is a factor of this big, fat, ugly degree 4 polynomial. And I could therefore write this big, fat, ugly degree 4 polynomial as a product of x minus 2 times this resulting quotient. Now, the resulting quotient is 2x cubed minus 1x squared minus 16x plus 15. That's the quotient. That's what you would get on the top if you did your long division. Well, I'm going to show you.
Are you multiplying your answer that you got and then making that the next number?
So pretty much you bring the first number down, you multiply, you get it right here, and then you bring it down. Get this number, multiply, write it there, bring it down. Get this number, multiply, write it there, bring it down. Get this number, multiply, write it there, bring it down. And it's so, it's enjoyable for me just because it's quick arithmetic, but it's so cool how you can get that. If we were to do the long division, all of these numbers, 4, -2, -32, and -30, or positive 30, those numbers would show up in the process. We would be seeing all of those numbers in here, but we'd also be seeing a lot of variables and a lot of time being taken up. Oh, yeah, we're going to do a lot of examples. Yeah. All right, so this is pretty much an explanation of what I just did. Okay, so this is the nuts and bolts of what I just did. We write up, first of all, we write up the coefficients of our dividend. And we got to make sure it's in decreasing exponential order. Yep. It's got to be in that countdown form. Bless you. So this was degree 4. So I started with degree 4, degree 3, degree 2, degree 1, and degree 0. Those were the 5 terms that we wrote up there at the top. But a big important concept is that what I put on the outside, my quote K value, I put 2 on the outside because that's the root of the divisor. Can you write that down? That the number that goes on the outside is the root of the divisor. The number that goes on the outside is the root of the divisor. When you say, do you flip the signs when you
Like, you're multiplying, flip the signs.
No, that's what's another nice thing about it. It is what it is.
Wait, how do you find the root of the 100?
Set it equal to 0, it's all. So you know how your divisor is x minus 2? X minus 2 equals 0. Add 2 to both sides, you get x equals plus 2. So that's why
If
that's positive.
if it was a positive 2, it'd be.
Negative would be on the outside. Yep.
And it, you mean, that's just the x minus 2.
Get you a pro.
Yeah. Like your next example, what would you put on the outside? You put -1. Your next example, what would you put on the outside? Positive 4. Your next, this is a hard one. Your next example, what would you put on the outside? 5 halves. Good. Okay, you see what I'm saying? See, and this one we'll have to be careful of. But let me go back to this explanation since Mitch and I were talking about it. After this, I mean, this process really is algorithmic. You just add it up, multiply, add it up, multiply, add it up, multiply. Wait, and then this gets you your quotient. This gets you your remainder.
Wait, what is like a voter?
See, Bess?
You're talking about putting it on the outside. Like, what do you mean?
Like that one.
With the, how the 2.
So you know how a long division has somebody that's on the outside of the carport? That is sort of like that. This number is on the outside.
I didn't see that. I don't know.
Gotcha. Frank,
Is it kind of similar to like multiplication? The Fibonacci conversion of multiplication. Multiply the number behind it instead of.
yeah. You can kind of see that. You can see it that way. Where like these 2 get multiplied, right to the result, tallied up. These 2 get multiplied, right to the result, tallied up. All right, thank you, too.
Yeah, it just looks like a multiplication version.
Not in here. Are you good at it? Sweet. I used to have one that
BJ didn't agree, didn't believe me.
we'll have to bring one next week. You can. Very nice.
Hey, Steve Rubik's.
Rubik's champ. Y'all know what's really interesting? You ever watch him do chewing gum again?
Come on.
Dude, you gotta knock it off with the gum chew. It's breaking a rule and you know better.
But like, who
I
did
like
y'all?
these Rubik's cubes that are huge, like big huge ones. I wonder what a little 2x2x2, how hard that would be.
That one. 2x2 is not very.
It's not bad.
Not hard. My personal best on a 2x2 is like 20 seconds.
Oh, snap. Okay.
What about your 3x3? Like 50 seconds. Yeah, mine's like 50.
That's cold. Good for you guys.
Hey, coach, somebody told me you keep extra bikes in here.
Yes,
So I was wondering, like, after school, sometimes if I could come ride with you guys.
absolutely. Yeah. So we got, a few years ago, we had a few folks that donated bikes. A couple of the brothers' bikes got donated. They're not very good. And then a dad donated a couple bikes that are pretty decent. And if you don't have one, you can come out and we'll figure out a way to get you on a bike. You would have to bring comfy clothes and shoes and water and a helmet. Tuesdays and Thursdays. You too, man. Hey.
Maths.
Mm-hmm.
It was a question, and on the number line, they were like between each other. It was I think it was an and one, and then for the thing, it showed